Hey, what's happening, guys? We got a racetrack, but we got to build the car for it. Looks like a fun kit. This is from that company, Mio Wow, and this is the D2-5 little electric car. And the way it works is you're going to have two light-dependent resistors here and two LEDs that are going to shine down onto the track. And we're going to use an IC here, an LM393, which is it's a comparator. I think it's a dual comparator, to compare the reflection of the light absorbed by either side, to let it know which side is seeing, more reflection from the white if we're over here, and this one's in the black, or be more white here and then black over there. And in turn, that will drive one of these small motors, which will mount through here, and surprisingly drive with a screw drive. So let me get set up and we're going to put this together and have some fun. Okay, I have everything all nulled out. And I like to do this for two reasons. One is just so I know where everything is. And you can see I have them separated. I have all the mechanical parts up here. Then we have logic components, diodes, resistors, capacitors, transistors, switches. That way, I'm now also familiar with the different things. Like, I know we have two clear LEDs and two red LEDs. Need to be certain where they go. Things like that. Check that if you have matching transistors or maybe an NPN PNP pair, so that you're kind of prepared ahead of time for what you need to look for. Then we can get started. Alright, well, you went to go get another beer. I did what I would call the fiddley part. And like, if you were helping a child or a grandchild build this, I would suggest that you do this as well. What I did is I assembled the rear axles. You have the wheel, then you have one of these T supports, and then you have a bushing, and then you have the gear. Just make sure the boss on the gear is facing away from the wheel, and another T support. And these four wires for the two motors comes, attached together, not stripped or anything. So I separated them into two pairs, stripped the ends, and tinned them. So when it's time to add them to the motor, the fiddly part is done. So now we need to identify these resistors. And 33 or so years ago, when I got out of school, I could do it. But I just don't do it that often enough that I need to remember. So I'm going to check them out using an instrument. Alright, after all that, we're ready to get started. We've got 1K, 10 ohm, and 51 ohm. I see 4 51 ohms, 2 1K, and 2 10. So that looks good. I'm going to put these all in, and then we'll come back and solder them up. Alright, so there they are, all in place. Now, this is nice. This is a single-sided board, so if you were to make a mistake, they are relatively easy to fix. In this kind of board, you don't have to worry about, being plated through holes and getting all the solder out. You just desolder on this side, and everything should be pretty doggone good. Give me a second here, we'll get a nice picture for you. And away we go. Add a little bit of solder to the tip of the iron for thermal transfer. And we just want to fill up the whole pad with solder. And when you pull it away, it should look like a shiny little mountain or Hershey's Kiss. I said Hershey's Kiss in a previous soldering video. I couldn't believe the number of people who didn't know what I was talking about. I thought Hershey's Kisses were worldwide. Apparently not so. Hershey's Kisses are little chocolate drops, um, like in the shape of a teardrop with a flat bottom, little bite size, and they're wrapped in usually shiny silver foil with a little piece of paper coming out the top. And the reason I say usually shiny silver is that around the holidays you can get different colored ones. So away we go, just soldering. Alright, you don't have to watch me do the rest of this. Okay, so we got them all soldered in. Now we can just come through with a set of flush cutters. Make sure you're wearing your eye protection. I have glasses. My clippers here are magnetized, so these don't fly away. But if you didn't have magnetic clippers, or these weren't made of magnetic material, they would fly everywhere. So what you can do is either just put your hand over top of it like that, or hold a paper towel or something. Otherwise, these end up flying everywhere in your house, and you will miss them, and your vacuum will miss them, and you will step on them, and you will curse my name for having ever showed you this, and we don't want that. I want everybody to be happy and peaceful and thrive and be curious. Yeah, that's good. And I don't know if I mentioned this, I started with the resistor because it is the smallest component on the board. Alright, what can we do next? Let's go with the variable resistors, potentiometers, trimmers, whatever you want to call them. These are either going to adjust the gain of the comparator or the gain of the driver transistors. I'm not sure which. I haven't looked at the schematic yet. Now, because the resistors are smaller, these are now able to sit pretty much flat, and you can apply a little bit of pressure, which allows things to go smoother. Now I'm switching to the other one, and the reason for that is that heat is the enemy of electronics, especially anything silicon-based, transistors, diodes, any kind of ICs. So I don't want to heat these things up too much. I mean, you're probably not going to hurt these resistor-type devices, but it's a good principle and it applies. The biggest thing is not the actual temperature. It is time and temperature, what I like to call dwell time. So if you can't get in and out with a solder joint in about a second, your iron just isn't hot enough. It is better, it sounds like an old proverb, it is better to have come in hotter and left quicker than to come in cooler and to have stayed longer. This is the way of the soldering. And make sure we get all those careless whiskers out of there. Da, 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 da. Well, I guess I probably should have done the IC socket first. It's going to be a little bit lower. So let's line up our notches. See the notch in there, notch there. They all go together quite well. it should take, literally no force to insert that. So you just want to make sure everything is, nice and tucked in there like that. So a little bit of blue tack, poster tack, this putty that kind of never dries but peels off cleanly is great for holding things in place like that. We'll get the opposite corners. Then we can take the blue tack away. See? Uh-oh. That's not down. Look at that. That's why we do this. So I'm going to apply pressure with my finger from underneath. And now it just snaps right into place where we want it. And I can go ahead and solder the rest of them in. Let's do our transistors next. They're 8550s. What I'm going to do is just bend a little tiny bit of a triangle into these legs. And of course I bent them the wrong way. Yeah, there we go. So then we can fit them in properly. They don't have to be forced all the way down to the board. Just where you start to feel some friction, you can stop. The transistors, of course, are what are going to provide the current to drive the motors. They are going to get a small current on their base, and that's going to come from that LM393 dual comparator, and it is going to look at the two signals coming from the two different light dependent resistors, and it's going to determine which one is stronger. And it is going to turn the transistor on for that one. The transistor will take that small current coming into the base and turn it into a larger current to drive the motor. See, when you break down a system like this, it's not as complex as what it first seems. There we go. I'm going to get this one soldered in. Well, we are getting down to the wire here. We are almost done with the top. So next I'm going to put in the LEDs. The red ones go on top. Long leg positive. There's your diode symbol right there. The arrow is pointing that way. The arrow points to negative. So we'll rotate it so that this is the positive. I'll put it in like that, and then I'm just going to splay the legs in an opposite direction a little bit, and then I can see I can let go, and they'll just kind of hang out like that. I'm only going to do one at a time of these, just because I want to make sure I get them soldered in nicely. Make sure when you're doing this that the tip of your soldering iron is touching not just the pad, but also the leg of the component. I'll try and get you a good close-up shot here in a second. Let's get this out of the way. Alright, so we'll do the other one, and then I'll move in for a close-up. So which way is the arrow pointing? Towards the edge. That's negative. Long leg positive. Just like that. Give them a little splay. Okay. The camera's almost touching my arm. It's a little awkward. So you want to be touching the leg and the pad at the same time. Then you can slide your solder in from the other side, and when it's hot enough, it will just flow. Just like that. Then you can remove the solder, then remove the iron, and you should be left with a nice little mountain. Oops, see, camera's very low, I apologize. I'll do it again. I'm just going to touch a little solder to the tip of the iron to help the thermal transfer. Then I'm pressing down on the pad and the leg. In comes the solder. Wait till it flows. The capillary action will take care of everything else. Remove the iron. Nice shiny joint. The last components on top are the electrolytic capacitors, and they are polarized, which means they have a negative and a positive. The white stripe pointing down to the short leg tells you which is negative. The silk screen on here are very nice. It has a little plus sign. So put your long leg in the plus sign, your short leg in the negative. You put your left leg in, you put your left leg out. Put your capacitor in backwards and you shake it all about. Alright, let's get these guys soldered, and that should be it for the top layer of this board. There we go. Yeah, some components take longer than others. My iron is set at 360 degrees Celsius. Or no. Yeah. 360. If I need to, if something's not soldering fast enough and I'm worried about damaging it, I'll crank it up to 400, but that's as high as I go, really. And I don't solder with the lead-free solder paste. The lead helps it flow. I'm not licking it, I'm not eating it. I think I'll be alright. But you do what you think is right. By saying all I mean is I can't give you tips on soldering with the unleaded solder because I don't use it. That's all. No judgments. I mean, who cares what kind of solder you use, right? Other than the EU. Alright, oh no, yeah, we've put switch on, yeah. Not bad. Thought we were done on top. Well, the switch will only go in one way, so you should be good. That's a tight fit, so that won't have any problem being held there. I'll solder it up and be back. Alright, we're on to the bottom side, which is really the only tricky part in here. We just need to put these at the correct height. So the LED needs to be about 14 millimeters and the LDR needs to be about 5 millimeters. So we'll go with the LED, long leg positive through the square hole. A little machinist rule here. I don't know how I'll be able to do this with one hand. Okay, probably not going to be able to, so I'm just going to adjust this so that LED sticks out about 14 millimeters. And solder it there. Hang on. How am I going to do this? Yes, I know you're all screaming at me because you figured out how to do it already and I haven't. It's alright. We must be resourceful, right? Generally in engineering, there's always more than one way to do things. There's probably one way that is the most right or beneficial way to do it, but there tends to be more than one way to get things done. And this is probably not the best way. I'm really fiddling with this. Okay, so I got one tacked, and that was simply the point of that, to get one tacked in there. And now I can come back and make sure that it's pretty good. Then we'll do the same, put the other one in here. And what I can do now, I was going to say I could put it upside down, and that will make sure they are at the same height, but then I can't get underneath the solder. So I'm just going to have to do the same thing and just kind of gingerly tack one in here again. What makes it hard is that you can't really apply any pressure. But I think I got it tacked. That one's a little higher, but that's easy enough to move. So here's what I'm going to do. I'm going to solder in the leg of the other one, which is at the height I like. Good. Then I'm going to reflow that first one that I just kind of jimmied. Okay. Now that one is soldered in pretty good. I'll trim the legs off. And now with no extra solder on my iron, what I'm going to do is just heat this up and get that more in line with that, just like that. Now I'm not going to touch that first one that I just reflowed. What I'm going to do instead is solder in the back one, and that way we're able to kind of pin it in place. Then once that one solidifies, I can come back, retouch that, and make sure we have a good joint. Trimmy, trimmy. And we are on to our last electronic component. Uh-oh. I think I may have lost a gear. Hang on. Okay. So I went ahead and soldered on the LDRs. If you look, the base of the LDR is just about the base of the resistor. So that's ready. Next thing we need to do is install our motors. So they go through there. I'm pretty sure they attach with the small, and when I say small, I mean really small, black machine screws. Yep. Alright, I'll get them in and then I'll be back. So I mounted the motors, and while I was at it, I went ahead and soldered in the motor wires. When I looked at the picture, it appears that, we just go Inside's on the inside and outside's on the outside. So that's how I'm going to solder these up. I put just a little bend in the tabs just so they're easier to get to. Nothing too radical, because those are seriously thin and could break off at any second. This one gear just is see what I'm saying? It is trying to ruin this whole project. Won't let me get it. Let's hope it doesn't escape again. Alright, now onto your 3G soldering. We'll go 3G uphill. No, I'm sorry, that's not soldering, that's welding. So that takes the solder real nice. These are pretty easy to solder on, that's good. Sometimes these can be tough. Just want to make sure I have good connections, that the wires aren't wobbling in the connectors when I do that. If you can see your wires wobble, even though they may look soldered, they're not soldered. So that's just my test for, did I actually solder those wires in there, or did I only imagine I did? I'll show you what I mean here in 1 second. Once I get these threaded in here. Man. Okay, what is your problem? There we go. In, stay there. In, okay. Oh, we have an escapee. I want to search every hen house, hill house, bunk house, rat house, dog house. Love Tommy Lee Jones. Okay, so what I mean is, if you go like this, and the wires are moving on the other side of the connector, they are not soldered in. Here, we'll get you more of a close-up view of the soldering. Touching the pad and touching the wire. Oh. Helps if you can secure it. And I'm just watching the solder flow. Once you see it start flowing, you can pull the solder away, keep your iron there for another second or two, and you'll have a great joint. Trust me, I know great joints. Speaking electronically only, I know nothing about plumbing. Well, I know one thing about plumbing. Excrement travels according to gravity. Alright. What did the battery connect to? Right here. Yeah, plenty of room for that. So I was looking for another set of screws for the battery pack, but there aren't any. But there are, or is, a piece of, as I like to call it, double sticky tape. Sounds like something you get at a Chinese restaurant. Give me some of them double sticky dumplings. Double-sided tape, obviously. Alright, let's solder these last couple wires in, which may be easier said than done, or not. Perhaps it will behave itself. Sorry I tend to ramble on. Soldering is like my relaxation thing, so you get like a flow of consciousness thing going on from what passes as a brain in my skull. That's going to be fiddly. Think I got her. I can just manage to not knock it back through the hole while I'm soldering it in. I don't like that joint. I'll show you. You want to focus? See how it looks round? So what I'm going to do is I'm going to clean off my iron, support the wire from underneath, and just reflow that solder again. Yeah, until I get a better looking joint. Now I like that. That's good. Alright, so we're on to the mechanicals. Alright, I'm going to start by pressing these worm gears onto the shaft. Get them started. Then I'm going to use the table and the motors themselves to help me set them to an approximate distance for now. So next up, we can install these guys. Oops, that one jumped away. This is going to be a bit fiddly. So, you know, like I said before, if you're working with a child or grandchild, you may want to help them with this part. Heck, you may want to help me with this part. I got that one started. I gotta get this one in there. Oh, almost had it. Alright, now if I can just get that screw going without everything escaping just like that, that would have been good. Fiddly bits. Fiddly bits, I say to you. Fiddly bits. Okay. Everybody, stay right where you are. Nobody move. Yay. And does it all mesh? Yes, it certainly does. All I gotta do is do that again. And the final piece, what they call the pivot nut. So we've got a bolt and nut combination here that I am now wishing I would have put on earlier. Like it said in the directions, you know. Because then I could have grabbed it with a wrench. But for now, my superhuman finger strength will do. So what it's actually going to pivot on is this acorn nut. There is the picture. It says install front support pillar, 1 piece M5 by 20 piece M5 nut, and 1 piece screw cap. So I don't really have any measurements. But that's what we got. So now I'm going to have to go grab a couple of charged up batteries. Okay. I think we're ready to test it out. I of course have no tape. But maybe a little bit of blue tack will come to our rescue. Because the show must go on, right? Alright, I don't know how well that's going to work. But we'll find out. Man, that's tight. Always feels like the batteries are just going to pop out of here. Man. There we go. Uh-oh. Hello, we're on. It got lost. But it works. We'll go the other way? No, and it says it'll only go one way. That is too cool. I think the problem is the light. Maybe it's too dark over here. Let me see. Can I adjust that a little bit? Get some more light over there. Let's see what'll happen. Nope. That obviously wasn't the problem. What's a rowdy little thing? Hey, it did it. And then we're lost. And we're lost. Come back. Get in there. That's fun. That's fun. I enjoyed that. Thank you to whoever sent that out to me. I don't know if it was me a while or if it was somebody else. That was a lot of fun. I'll put a link to the kit down below. I hope you guys enjoyed this. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons and everybody who helps make this channel possible. That's it. I'm out. Peace.